Question 17. Diffraction patterns obtained from X-rays and electrons. The pattern from an electron experiment is combined to the same scale with one from an X-ray, and we get the same diffraction pattern. The X-ray energy that produced the pattern is that. Find the voltage required. Okay, so same pattern. Same pattern, therefore same momentum, therefore same wavelength. Okay, so the energy of the X-ray is hc over lambda. So that comes from E equals hf, which is equal to hc over lambda. So from there we have the energy of the X-ray is 1.75 by 10 to the power of 4 is equal to h, which is 4.14 because we're dealing with the actual electron energy, or with the smaller energy by 10 to the negative 15 times by 3 by 10 to the 8. When I say that smaller energy, we're actually told that it's in electron volts, and that's over wavelength. So therefore our wavelength is going to be equal to 7.097 by 10 to the negative 11 metres. So if that's the case, the energy of the electron equals h squared over 2me lambda. Now, I want to explain how we get that. So we'll just have a little bit of an aside here, because you could put this in your formula sheet, but just as a little bit of an aside, we know that BK of matter is a half mv squared. We also know that the de Broglie wavelength is equal to h over p, which is equal to h over mv. So we can rearrange it and we get v equals h over m lambda. So then if we substitute that in, we end up with BK equals a half mv squared. So that's equal to a half by m by h squared over m squared lambda. So one of those will cancel out with one of those. And we end up with BK equals h squared over 2m lambda. I forgot to square that lambda down there. 2m lambda squared. So that's how we get that. So back to what we were doing. Substituting values in. Energy of the electron is equal to h squared, because we're dealing with the matter now, 6.63 by 10 to the negative 34, all squared, over 2 by mass of an electron, 9.1 by 10 to the negative 31. I can never remember that last bit, times by lambda squared, times by 7.097 by 10 to the negative 11 squared, and that gives us 4.795 by 10 to the negative 17 joules. Now, I've taken up far too much room on this. Now that's in joules. So if I want to know the voltage, I've got to divide that by charge on electron. So divide by 1.6 by 10 to the negative 19, 1.6 by 10 to the negative 19, and that will give me the voltage, which will be, when rounded to significant figures, 300 volts. Now that's because we've divided our energy by charge an electron. So that will be the voltage required to accelerate that electron. That's that one done. Question 18. We know that electron energy level diagram, higher energy level to a lower one, they emit photons. Yep, bog standard question. We've got a wavelength of 627 nanometers, equals 627 nanometers. Show that the energy photons produce this emission line is 1.98 electron volts. We know that E equals HF, which is equal to HC over lambda, which is equal to, because we're talking electron volts here, 4.14 by 10 to the negative 15 times by 3 by 10 to the 8 over the wavelength, which is 627 by 10 to the negative 9, gives us 1.98 electron volts. So we've shown. On the diagram above, draw an arrow that represents a transition line that will emit the photon with the wavelength of this. Clearly show where the arrow starts and ends. So we want something that's going to give us a change of 1.98 electron volts. That happens when it comes from n equals 4 down to n equals 2. Because if we go 3.83 minus 1.85, that will give us 1.98 electron volts.